In this video, you will learn about live fuel moisture and its importance in wildland fire. You will learn 1. What is live fuel moisture and how is it measured? 2. How do seasonal changes in plant types affect live fuel moisture? 3. How do other factors influence live fuel moisture content? 4. Why is live fuel moisture important information to fire managers? 1. What is live fuel moisture and how is it measured? Live fuel moisture is a measure of the amount of water in living fuels, which include both woody and herbaceous plant material, and is a critical factor that influences wildland fire behavior and effects. It is expressed as a percent of the dry weight of that fuel. Moisture content of living vegetation can range between 35% to 300% during the fire season for typical wildland fuels. What? 300%? How is that possible? Stay tuned, I'll explain that next. First, notice the big difference between the moisture content of live and dead fuels. Dead fuel moisture is discussed in another video. How can living fuels have up to 300% moisture content? Living cells have the capacity to hold large amounts of water, which plants need for growth. Notice from the chart, however, that only brand new growth contains up to 300% moisture content. As plants enter dormancy, their moisture content drops to around 60%. The following are photos of both herbaceous and woody plants, perennials and annuals at various stages of development. This is new growth on a deciduous woody perennial, and these are green perennial grasses. The live fuels in these photos have moisture contents of about 300%. Here are herbaceous annual plants and grasses, sprouting with all new growth. Also examples where moisture content will be around 300%. On this evergreen tree, the new growth is lighter while the old foliage is dark. The new growth has about 300% moisture while the old foliage only has about 90 to 120% moisture content. The maturing foliage on this tree is about 90 to 120% moisture content. 2. How do seasonal changes and plant types affect live fuel moisture? The moisture content of live fuels is always changing, and how it changes can vary by plant type. For example, moisture content of these aspen leaves would tend to be highest, around 300%, during the period of most active growth in the spring. In the fall, the coloration of leaves begins the period of dormancy for the trees and loss of water from the leaves, with moisture levels of about 60%. However, the seasonal change in live fuel moisture varies with the type of foliage and type of plant. This graph shows how the moisture content of new growth starts at a peak of 300%, then rapidly declines, while old foliage maintains moisture levels of less than 100%. We also see differences among different types of plants. For example, annual plants and grasses, as well as leaves of deciduous shrubs and trees, tend to have higher moisture content because they only have new growth. Evergreen perennial shrubs and trees carry old foliage year after year, which has a lower moisture content. Most ecosystems hold a variety of annual and perennial vegetation, and each species will have a different seasonal growth habit or time of the year when their fuel moisture content is highest. For example, for ponderosa pine in the southwestern United States, the period of most active growth occurs in the spring after snowmelt. For many understory herbaceous species in these forests, however, the active growth period is different, occurring in the summer during the monsoon season. This different seasonal growth habit can also be seen in grassland ecosystems. This graph shows how the moisture content varies throughout the growing season between the annual invasive Bromus tectorum or cheatgrass and native perennial grasses. Notice the difference when the growing periods peak. Notice also how rapidly the moisture content drops for the annual cheatgrass. Perennial grasses and shrubs are less sensitive to seasonal and short-term weather variations due to their larger and deeper root systems, which allows them greater access to water. Because of this, they tend to retain some greenness throughout the growing season. Perennial grasses also tend to cure or dry out later than annuals, which is an important consideration when assessing fire potential. 3. How do other factors influence live fuel moisture content? Factors such as weather and topography influence atmospheric temperatures and relative humidity, which in turn affect live fuel moisture. Shade from clouds or overstory canopy cover can lead to higher humidity and reduce the evaporative loss of water from plants, allowing for higher live fuel moisture content. Those same live fuels can be influenced by wind. Wind can speed evaporation rates to decrease fuel moisture and conversely increase moisture content when high moisture wind blows across the fuels. In this graphic, you can see that shade can have a dramatic effect on fuel moisture content of live fuels. The air temperature in this example is 10 degrees hotter in the sun. The surface temperature is much higher in the sun, and therefore the fuels in the sun will have lower fuel moisture content. Topography can affect all sizes of fuels. South-facing aspects tend to be hotter and drier. Fuels at high elevations have a shorter growing season and generally greater fuel moisture content due to the lower temperatures and higher humidity. Narrow canyons can provide more shade and are cooler than more exposed areas. 4. Why is live fuel moisture important information for fire managers? Live fuel moisture affects the potential for live fuels to burn. However, live fuels are a main component of fire spread only in certain systems, such as chaparral in California, saw palmetto in the southeast, and crown fires fueled by living trees. In such instances, live fuel moisture content is a critical input for making fire behavior predictions. And lastly, managers use live fuel moisture as a valuable indicator of drought and long-term moisture stress. And now let's review. 1. Live fuel moisture is defined as a measure of the amount of water in living vegetation and is expressed as a percent of the dry weight of that specific fuel. 2. Live fuel can have moisture levels between 35% and 300%, with the highest amounts occurring in new vegetation during periods of active growth. The period of active growth differs between plant types. 3. Topography, atmospheric conditions, and fuel properties affect live fuel moisture levels by influencing the evaporative demand of water from plants. 4. Knowledge of live fuel moisture is critical for fire managers to understand potential fire behavior and fire effects.